All right, welcome to today's stream. We're gonna be programming again some more Snowjob instead of s&box. The playlist for today is very chill because I'm trying to put all the babies to sleep. Go the fuck to sleep. This video is the VOD is immediately going to die, and I'm sorry for swearing so early. But today we're gonna continue on where we left off, and we're gonna have a full session today because I started earlier today. It's why we're getting a full session. It's why I'm starting so early today. This segment. Usually I do it maybe the last 2 hours. Today we're about 3.5 to 4 hours of this, so we have a fair amount of time. Last time we left off, we got basically nothing done, and we got some ideas of like what we needed. We needed some way to notify the user that their snowball. Well, we need some way to notify the player that the snowball that they roll is like no longer stuck, right? And I won't explain what the project is. You just have to hope that you understand what's going on. The problem is that sorry, this is the plan for it today. There's like a lot of plans actually. The problem is that even in doing that, we recognize that we need some way to actually give like a notification to the user, to the player. Sorry, I'm still in a bit of a corporate cuck mindset. I came from, you know what I mean? Like I just finished, like, you know what I mean? Like my work stuff. Sorry. But the idea is that we're going to be able to notify them such that when something does happen, they're able to recover on their own and know that if they keep pushing, the snowball will blow up. So this way, we can set a cap on the way the snowball grows. We cover every edge case where it could be stuck, and we give the player some way to recover from that state without us having to manually intervene. So, of course, there's some caveats, right? If the snowball gets stuck, say, inside of a box, let's say you're pushing the snowball down a tunnel, and eventually it grows so large that it sort of covers the cavern walls, and there will always be a floor, right? Poop? What? Where's it again? Where's the diagram? Here we go. Say you're building a snowball and it's in like these cavern walls, right? It's not gonna fit. So at some point it will get stuck. I think that case, we just have to rely on the players being smart enough not to do that. But also that's necessary. Like, it's not really a problem, it's more of a challenge, right? Because then I can do a tunnel where it's like, can you make a snowball grow from start to finish and then make it through? Kind of like the game of Sisyphus, but with a snowball that like grows, right? That gives a lot of flexibility for game design actually. So it could be good. But we'll see how it goes. Hopefully this does end up being fairly straightforward. Now that we have some system in place to have notifications in the UI, roughly, it's more of a placeholder for now. I still need to figure out how to do dynamic UI. We can figure out actually how to like apply the highlighting to the object, and then figure out some rules around when do we consider it to be safe again. From there, we then need to figure out a better controller for the snowball movement. We've just been sort of, doing it in a pretty janky way. The janky way right now is to use the character controller to control a snowball. Obviously, a snowball doesn't really need to jump to some degree, and really the way it moves is completely different. Because if a snowball stays still, even if it's on an incline, you kind of want it to slowly roll down at a very different pace. So there's a lot of different tweaks to it that have to happen on its own. But collision code overall is going to be roughly the same. So we can try, I think, to extract the collision code. I think we just take it from the character controller itself. I think it's fine to just copy that code like pretty much verbatim, and we'll just see how it goes. Because I'm really lazy to write like full collision code. Like the more that I think about it and the more that I've like read up on it, it's like I don't even know how I used to write it before, right? But basically, it seems like everyone has the same solution. You do multiple checks, and if you're close, then just keep you on the same plane. Otherwise, pop through. So we'll see how this goes. Hopefully it's fine, but being a physics-based system, it should feel a lot better than what it currently is, which has like a weird step-up like feature as well, which doesn't really work for the slopes that we're going to have. Put a big flashing warning sign and sirens and alarms and me screaming in case the snowball is gonna break. Yeah, and then we like do like the soy jack, right? So I can even put like a soy jack on the screen. That's like, whoa, look out, whoa, it's gonna break. No, but see, the game, it's about the zen and art of snowball rolling, right? It's like the zen and art of motorcycle maintenance, but for rolling a snowball. So I don't want to like scare people. I'm saving that for the horror game idea, which I have a horror game idea, which I think would work very well in s&box. So again, a lot of the game ideas that I had before that I was thinking like, how many of these could be made within s&box, right? Because there's a value proposition. One, there's a problem. s&box is a bit limited in the way that it handles like data storage. Well, not anymore. The newest version that they released doesn't have that issue. At least by the August whatever devlog. As well as there's a problem with the way that the networking is right now, or rather how it serves assets. If your game is too large, it might take a player a very long time before they're able to actually like play your game, because you have to download the entire game. So there's some downsides, but what you get in return is a network model that just works and that has the viability to be some pretty interesting things. Particularly around the use of the voice and the fact that the Source engine kind of just handles networking pretty damn well as is, and it just gives you an easy way to implement that and integrate with that with little to no changes on your end, plus a lobby system that just works, right? So there's viability there. We just need to figure out ways to make use of it, and I think I have some ways. We'll see how it goes. But those are future projects. Let's focus on the net on the now, which is we need to now actually apply a highlight, change the color. So this highlight and changing a color thing, there's a bit of a problem, right? Right now, if it gets stuck, so we know that it has no new position. So maybe this should be renamed into. We'll rename this into like door stuck or something. Yeah, we'll do like, I don't know. Hello? This why. I don't know why it doesn't. I need to reload all these files. I need to reload every single one of these files. I can't believe it. I'm pretty sure that's the problem here. Is that the way that this works? Wait a minute. That's not true. It's my keyboard. What the fuck? Hey, dog. Yo, dog. Yo. Yo, man. Huh? Clearly it works. Okay. Oh, it doesn't work here. Huh. That's weird. So it only works within a buffer. Okay, well that's weird. Whatever. We'll figure that out later. How come the rename doesn't work, eh? You know what? Actually, the entire indexer is kind of busted. What happened? I need to reload the editor. What song is this? Please tell me I'm gonna die. Please, song name. I don't know. I actually don't know. It's a part of a larger playlist that, by the way, this playlist is illegal. It got taken down by DMCA. So even if you listen to this, I can send you the links to it. I mean, I can just tell you, just like search up Fruddle, Fruddle. It's a giant playlist of like game songs. And you can basically, I think in the game itself, it's like it has everything. You know, how did you get it so quickly? It's a Nobu Umatsu. It's a Final Fantasy song. How do you know? It is a Final Fantasy song. It is. Oh my god, you're actually right. But how do you know so like, quickly? What the fuck? Are you a Final Fantasy stan? Are you about that life? Do you think it vibes? Do you think it has that aura? Anyways, let's like say like this is door stuck. Okay, so if, or rather, I mean, I guess like, can scale. Okay, so if this can't scale, for instance, if this can't scale, we provide a highlight and then we do it here. Shazam-like extension for Chrome. Really? There's actually one? That's actually a great extension. Please link that in the Discord because there's no links here. Sorry. This is why Chad is the main character. You've been timed out once. Don't make me do it again. I'm just kidding. I'm just kidding. it was a joke timeout. So now we apply the highlight, right? We have the color for the highlight, but there's no way for us to actually take out the highlight. So we need to finish this like logic of avoid my mistakes of the me. Why did I do this? What was this again? Oh yes, I remember. I was putting it off until tomorrow to like deal with. So basically, there we go. Basically, what we need to do here is we need to figure out what the logic is for determining when the highlight should disappear and what exactly it means for the highlight, like for the snowball to be stable, right? Everything is based around movement. So if the snowball isn't moving, it isn't growing. We don't really have a good way to, I guess, like really encode the idea of not moving. Right now, it's based on acceleration, which is a bit too many layers, like too deep into the inner workings of a snowball. When realistically, I'd want this to be abstracted to some degree. But this is fine because a lot of the movement anyways is built around the positioning. So for instance, the positioning handles of sort of how it grows and scales. We need to clean this up too, actually. So today, we're going to clean this up too. We're going to get we're going to get like the either deciding to destroy the snowball or keeping it highlighted done. And then I think we're gonna finish up the train stuff as well. I think the train stuff is gonna be easy to do because I want to switch it to a purely event-based system that isn't really tied to the idea of like the sandbox state. Because there's no real need to. Like it really was just a decision that I made to make it easier. But it's easier to manage if it's just like purely like points of data, like straight up like basically identifiers in the set of arrays, right? So it's way easier there. And to do it only at the one point and caching all the data, because like it's not like you're gonna gain strength as you're pushing something. Oh, is that true? We'll figure something out. We'll figure something out. Maybe there needs to be like an update and then like a push or like a thing. We'll figure it out. But I think there's a better model for the train that's easier to understand. That's event based versus something that's right now pretty imperative. I think at least. Can we have a story time? No. That's during Halloween. There will be a story time. Chat. This is my moment. This is my moment to like do stuff. Do I talk like this when I do my own projects? No. I talk in my head. It's actually the hardest part about streaming programming is learning to talk out loud so you know my thoughts. When I do it on my own, like literally me at work with my coworker is like, this is how the meetings go. So they start or I start by going like, yeah, so this thing here, it's like, and then they stop talking or I stop talking, and then the other party goes, yeah, I had the same idea. So and then me and my coworker, like the one that I you know, this is the dude who I pair program with exclusively. Like this is the one dude who this is the only person, well, one of two people that I can pair program with, and it's what we usually do anyways, right? We'll go silent for 30 minutes or like 30 seconds, anywhere between 30 seconds and like 30 minutes, and we'll be thinking about things, and then someone will open their editor, start changing things, and then we'll just say like, yeah, that's what I thought too. And then when it gets to a point where like something doesn't work, we'll say like, wait, how about this? Like instead of that, we'll do it like this, and then they go, oh yeah, actually that makes sense, and then we just go like that. It feels weird, right? It's a bit like the description of like Sanjay Gemawat and whoever else his partner was, right? At like the level was it 17s at Google. It's a bit like that, but there's more talking in between where we're trying to figure out things and where we're trying to explain concepts to each other. Other than that, if I'm not pair programming, it's like dead silence. So even me talking out like this is not the same as like how I do it at like work entirely, because again, it's mostly silent. But I'm trying my best here to keep, I think, to explain my thoughts. Otherwise, it's like very hard for you to understand, because like programming is 99% thought. It's 99% thinking. When you know what to code, writing the code kind of like happens then like naturally, right? It's why AI stuff for coding could have a use eventually if it doesn't choose the wrong answers, right? Because like the way it works is it just chooses what it's basically probabilistic token, like text tokens, right? Basically, I mean, very simplified down. It's just a probability and like text tokens. If it gets better at that, theoretically, there's a realm where like you as a programmer are mostly just gonna be telling it what you want to some degree, and it's basically just giving you stuff, and you say yes or no. Which is kind of what you do now. It's like you like think about it, you imagine the code in your head, and you think yes or no, or like you even think even in the I think a higher level sense of like, does this work as a system as a whole? Yes or no. And then you just need to figure out how to like translate it into the language that you have. It's like learning a language in it. Not really. I would argue it's like learning a set of tools. I think specifically learning programming languages is like learning a set of tools. I think it's easy to think so because it's like it feels like a language, right? It has very similar effects and like artifacts. But the difference is that it's not malleable. It's not a very malleable thing to like play with. Like you can't just say slay and then vibe in a programming language, right? But like the equivalent of that in a programming language, because the entire thing wouldn't work. You must play within the rules, otherwise it doesn't work. Language is far more flexible and way easier to like deal with. Programming languages, because they're so strict, means it's more of like using a tool or like a multi-stage like machine than it really is a language at its core, I think. That's called thinking. It's not Mass Effect, no. I think it's Cave Story. That last one might have been Cave Story. Anyways, so we know what to do, but we're gonna figure this out. We're going to figure out the snowball's lifetime. Last time we decided, if it's no longer moving, so if it has no acceleration and we know that it's going to stay still, we're going to say, okay, door stuck time pass equals 0, and also it won't be destroyed, right? So we know that it's no longer stuck and that it won't die. Problem is that we still need some way to say that it's stuck, right? Because if it's still stuck while it's there, we need to count the timer down. If it's not stuck, we don't want to do it. Right now, the way it's written is that the moment that it starts moving, even if it's not stuck, it'll start to break. So we do actually need a flag. Another flag that says is stuck. This is a disaster. What was it called again? Determine snowball lifetime? There we go. This is, oh god, this is a disaster. So it's now no longer stuck. So we can just say that's like false now. But we also need to return it back to true if it does happen here. So yeah. There's actually, oh god, this is very complicated. But anyways, it is stuck here equals true. So when it's stuck, we do that. If it's greater than 3 seconds or so, this will be configurable. So to do, make this threshold configurable at some point. Then we'll figure out what to do here. It's stuck and now had a helper function called stepbro. Sure, fine. Look in VB, yeah, and then stepbro. So this function is now called stepbro. It checks if it's stuck, and then if it is stuck, then it does things. If it's not stuck, it doesn't do anything. So if it's not is stuck, just return. Like we don't even care about the state. This only handles what happens when you're stuck. It also needs to time down this timer. So door stuck time pass plus equals time dot delta. There we go. Very simple, very straightforward. Now it makes sense. But there's some things here, right? Last time we touched on this. When you break the snowball, is there a way to propagate that event? So for instance, we know that there's an on destroy, I think, right? Yeah, there we go. And we can notify things that's been destroyed. But when we notify things, for instance, right now the train, for instance, right? The train is the one place that it needs to be notified because then it needs to know to break the entire train that's currently on. What does that mean? Well, there's a problem because right now trains are based on references to game objects. But when it's being destroyed, doesn't that mean that the game object doesn't exist anymore? So this was a problem that we identified. This will need some testing, but I even think that there's a better way of doing this that doesn't tie it to a reference to an object. But at the same time, now that I think about it more actually, whether or not you have an abstraction for a reference to an object, say like an ID or something, like a UUID or something, or you have a reference to the object itself, you run into the same issue anyways. The ID is flexible because it allows you to do things like, persistence across sessions, right? So it's primarily what they're used for because in a database, you may have a row in your database, but in your application, in memory, you don't have that yet. That's why the ID is there because it allows you to sync the state of your application memory to your database state. Here, there is no such thing. Everything is contained within the session, within the memory of this running lobby at the moment, which means we don't even need to think about we don't even need to think about an ID. We only need to care about an ID if the game object reference that we get by the time it gets destroyed isn't valid in some way. Yeah, okay. So this still is fine, but no ID because simpler and doesn't really solve the problem either way since it requires a stable reference regardless, right? Very simple. So we go back to snowball. We have the on destroy. And I think what we're going to do, actually, does this actually allow me to do symbols too? Yeah, it does. Okay, so on destroy, snowball. Yeah, it does. Sick. Perfect. It does do symbols. Perfect. So I can go immediately to it. Nice. That's a lot better. Okay, so what we're going to do instead is this. We're just going to hope for the best that when it gets destroyed, that we can actually react to what's happening. So I think that's great. This is basically done, but it means that we now need to clean up this. This is an ungodly mess, okay? There's 3 particular states that a snowball can be in, right? A snowball can either be growing. So snowballs Can snowballs, can snowballs, there we go. Snowballs can either be growing, shrinking, or stuck. These are the three main states of a snowball. These are all dependent on the movement of the snowball. Balls. These are all dependent on the movement, which right now, that's a terrible O. Right now, we've codified the movement in terms of positioning. So really, this is just last position versus current position. And that's fine. What we currently have, though, in terms of the logic, is a meshing of these three concepts into one. Right now, the code is a mess because it considers all three cases at once. When really, you kind of want a state machine to move you through. And the problem is that we never really defined when it should melt, when it should grow, and when it should be stuck. Again, because it was sort of like the MVP mindset and for the game jam. But either way, it's MVP for Christmas. But for Christmas time, we have like a couple months, right? We should take a step back and really define when a snowball should grow, when a snowball should melt, right? And we can just encode this within the code. Ideally, no documentation needed. If we can make it as clear as possible, that we should be good to understand when it should move. What is going to happen, though, is that there's going to be a series of things, right? It's going to be a threshold of some condition, a threshold of time, because it's all going to be based around time. I don't think there's an easy way to do it, just because the game is kind of physics based anyways, and time is a thing that you can use within physics to determine things, and so it's easier to model it that way. It matches a player's expectations intuitively based on real life experiences, I think. And it's simpler as a whole to model versus replicating an entire environment and applying artificial conditions to it based on some other conditions. You know what I mean? Like, it gets way too complicated. So doing it based on just time alone and saying like time and then the intersection of like time and movement is way easier than like doing like movement and some random condition that we have to make up out of thin air. Like maybe the player is like attached to it, which is like a whole different thing, right? Like it's way too hard. So instead we do this. To grow, these are, we're gonna go over. To grow, we're gonna take it simple here. Real simple. I know I've been saying that the entire time and I haven't done it yet, but just trust me, real simple. To grow, you must be moving. Okay? So we know what the moving is. There must be movement. We know what that means from over here, okay? And it must be consistent for a set number, for a set time. Moving for a set time. So for instance, you have to be moving for at least, let's say, 3 seconds, right? For the snowball to really start to grow. So you can roll a snowball, maybe even lower. I think movement should start immediately. Like as soon as you start to move it, it should feel like it's growing, right? Right now, it's based on the player's attachment to the snowball, but just basing it off of movement alone, I think it's way easier. Because it also provides flexibility, because then anything can start to make it grow, not just the player. So it has to move for at least 1 second before it starts to grow, right? And we still keep the growth at growth equals the mass times the steroids. Yes, the steroids. I'm taking a term from MOBAs in that sense, where there's a multiplier of your power defined by some steroid value. This is more flexible too, because if we want the snowball to say grow, right? This is not a Yagni thing, okay? So Yagni is a principle of like, you are never gonna need it. That only applies for things that you know aren't gonna be on the docket. I know that I'm gonna want items that affect the snowball and affect the player's stuff in some way. So I need to think about them now, if I can, in order to integrate them into the initial design of things. So it's easy to add things. In this way, it's very easy to add, say, liquid snow that you pour on a snowball that makes it larger, right? Because you just increase the amount of steroids, or you increase the mass. And so you have two different levers to like pull. One is a multiplier, so think of this as the multiplier. And the one is it the integral? I can't remember the like name, but one is sort of like the real number, like the actual. This is the linear. This is the constant. This is the constant. This is the constant, right? We have a constant and a multiplier. So kind of similar to any other RPG stat system that you've ever seen, but for a snowball. It's just something coded the same way. So we know this much. To melt, so this is grow. I mean, you can see by the symbols. This is good art, right? This is top tier art. Look, I'm a genius. Look, fucking beautiful, man. For it to melt, you must not be moving. So you must be still for about, let's say, 3 seconds, right? I don't want it to happen immediately. So for 3 seconds. Oh, also, the growth mass times steroids times distance. So the more that it moves, the more that it grows. But also, actually, there's one more component. So if you move a large snowball, it obviously doesn't grow the same amount, right? Like a big-ass snowball. So a giant-ass, big-ass snowball. You move this thing, say like from here to like over here, right? In terms of like the other, like, because these snowballs don't actually roll. It's just an animation, right? But you want to model it roughly the same way. Basically, it would be able to do a full rotation faster. So the distance to move a full rotation of a smaller snowball is way smaller than a larger snowball. Which means for the snowball to grow, it would take longer and more distance to be pushed because you'd be trying to collect more snow on it, right? It's like that's the thing that I'm trying to model here. And to model that very simply, you can just do distance divided by the mass. Let's say, right? And then, so let's see this. Really, there's more parts to this actually. It's really, mass equals, just do plus equals. We know what plus equals means. Plus, is there a mathematical symbol for plus equals that isn't like a programming symbol? This is a song from Okami. If there's no symbol for that, then I guess we're just doomed. But it's plus equals mass. Let me think about this. You increase the mass, another thing, times the distance. The mass has to grow. Really, it's the growth equals the mass. Because the mass is the scale. So really, yeah, this should be like this. There we go. Okay, now it makes more sense. Sorry. Because I forgot what I defined mass as. So mass is actually the actual value of the weight of the thing. It's also handy because mass technically maps back to the physics model, which is going to be either really good or really bad, depending on how I've done it already. So we'll see how it goes. Hopefully, it ends up being roughly the same and still good. So mass equals the mass. Mass plus equals mass. I just keep saying mass. Mass. Mass times steroids times distance divided by mass. Because the amount of distance that you've covered should feel like less depending on the size of the snowball, right? So you moving 5 units is going to grow the snowball less compared to you moving 5 units at the smaller size. Because realistically, we're just modeling this within our data model, but realistically in real life, it would take you longer to do a full revolution of a larger snowball compared to a smaller one. Straightforward. Is that straightforward? I think it's straightforward. It's more straightforward than most things here, so I think that's fine. Now for shrinking. Must be still for at least 3 seconds. Larger snowballs, similarly to the movement, I want them to grow and melt at different rates too. A large snowball is going to grow at a very different rate and melt at a very different rate compared to a smaller snowball. I think it's very important to make it feel like that, because otherwise it feels like your hard work just kind of disappears the moment that you let go of the snowball. And the amount of effort that it takes to grow the snowball, because it's being divided by the mass, is then out of sync with the effort that it takes the game to melt the snowball. So basically, you want the opposite of this. You want the rate of melting to be times the mass. The larger it is, the longer it takes to go to here. The smaller it is, the faster it goes towards this. That's really what we want to aim for, right? You're looking at effectively percentages in terms of how it loses size. But percentages are not really the great way to model it because it's the opposite of a percentage, right? 1% of 100 is 1. 1% of 1 is like 0.01, right? The scale gets a lot smaller as you go smaller, and as you get the scale of a percentage. Sorry, the magnitude, like the actual what's that term? The actual realized like value, the magnitude of the rate of change, if you do it by percentage, is far greater for a much larger thing compared to a smaller thing. We need to invert that relationship such that it's really based on the inverse of the mass. How? I'm not a mathematician. I don't know. We're gonna figure that out. I can only say it, but I don't know. This stream needs a laugh track. Insert laugh track. Were you there for the Diablo 2 thing? I don't think you were there, but there's a whole meme on this thing now. Okay, well, if you weren't there, then you don't know about insert laugh track or Omega lol. Again, that was a very long stream for me, but for you, it was dead silent, chat. For all of you, it was very dead silent. For me, it was a bit of an experience. You hate it here. Why would you choose to be here? That's a good point. Why would you choose to be here if you hate it here, huh? Next time I come into your stream, I'm gonna tell Team Purple to be mean to you. So, what does it mean to scale it by the inverse of a percentage, right? And what does it mean to melt? Well, I do want it to melt by some consistent factor. And I think right now, the model that I have it melting by, way too confusing. I think the way that it melts right now is very, very odd because it scales based on time, which isn't really the accurate measure, right? It doesn't matter about time. Time is not really the reason why it's sort of starting to like melt. In fact, time doesn't really exist here either. Time is only the condition, and leaving it like that makes it way easier. No, yeah. I see your lies are getting to you. Your lies are getting to you. And so what I think I'm going to do instead is this. I'm going to focus primarily on doing it purely through the mass itself. Makes it way easier. So we do instead this. We do, whatchamacallit? Instead of the time-based system that it is now, we do a flat percentage. So it's going to be a flat percentage decrease. Flat percentage decrease. Decrease over time. But the rate is effectively, the rate expressed as a percentage is consistent. The rate as an absolute value, however, changes. And the only way to do that is to sort of inverse the way that it works on mass. So really, you want almost the flat percentage divided by the mass to really make it work. Because let's say you have like 100 mass. So snowball is like 100 times the size of a normal snowball, right? And you have 1%, right? So 1%. 1% divided by 100 is like 0.01% melting speed. Which is great, because that feels good, because then your large snowball doesn't disappear out of existence out of nowhere. However, a small snowball, let's say you have a snowball that's like the mass of 5, right? 1% divided by 5. What the hell is that? I don't know. Calculated.com. There we go. 0.01 divided by 5. 0.002. Eh? Is my thinking wrong? Maybe. Should it be divide or should it be multiply? wait a minute. Wait, or like 0.01 divided by 100. That's why. Sorry. Right, sorry. It's already 0.01. Sorry, 2 zeros. Here you go. Right? So you get like a very, very different rate of like melting. Maybe I do want this to scale though. If it's 1% for the entire time, it gets kind of boring, if that makes sense. There should be a ramping amount over time. So maybe we do include time in this, which I don't know. I'm kind of worried about that. So we do ramping instead. So we do a ramping percentage over time that increases over time. Ramping percentage decrease over time. Ramping percentage that grows over time, which is then, what's the term affected by? Functions. Scaled by mass of balls. So let's say ramping percentage, okay? So it starts at 1%. So let's say the moment that it starts melting at, 1%. So this is like step number 1. It's starting to melt at 1% at 0 seconds, right? Welcome back, chat. 0 seconds. And then over, let's say 5 seconds, because it starts to melt faster and faster. Let's say it starts to melt faster because it sits in the sun, right? I think it's good. Maybe even over like 10 seconds. I think keeping the cap pretty damn high is like good. Because it makes it way easier to determine. And like way easier to like start to it puts pressure on the player to use it at some point fairly quickly. Over 10 seconds, it should then become 10%. 10%, that's a lot though. Because 10%, and over 10 seconds from then, the snowball will basically disappear. Well, it's 10 times 10 times 10 times 10 times 10. It's basically that like curve, right? I don't know if that makes sense. Like right now, if you do 10% here, then the curve is like this. When I kind of want it to be like this, like way longer of a parabola, of an arc of a parabola. This is fine though. I think this is fine actually. 10 seconds. And this rate is not linear. I don't want this rate to be a linear change. I want it to be an exponential. So it starts at 1. At 2 seconds, it should be like, at 2 seconds, it should be like, 1.4%. At 5 seconds, it should be like 3%. At 7 seconds, it should be like 9%. No, it should be at like 5%. And then at 9 seconds, it should be at like 9.5%. Like it should scale very quickly. Caps out of there. This gives you like a lot of time to play with initially. It doesn't take it takes a while before it really kicks in, and really maybe even like 30 seconds actually. So it really takes time, right? This way they don't sit there forever, but at some point they will die. And then you just do that. So I think that makes sense. So we do it like that, ramping timescale. Then we do this, which is the percentage. So melt rate divided by mass equals effective melting rate. Now you'll be thinking, if I had a stream in the shower, just like the other chatter, you know what? That's when I do think about that. Because like, I'm sure the women in my chat probably go through this when they're streaming, when they sort of like think about this. Like it must be at the back of your head when you realize that like somebody could, again, because it's a whole talk about the objectification, right? Like the objectification happens. Graphtoy.com might help with graph/Brabla. Maybe for graphing it. Like what is this exactly? Maybe for graphing it. Yeah, no, maybe for graphing it, but not actually to like do it. This I think is a better for a visual thing. But either way, I would still need to somehow convert these into something within the code, right? And if I'm doing that, I don't really need to look at the graph to know what it is. Because if I figure this out, then we're already done with this, effectively. I appreciate it, though. It's a cool toy, but I don't think it's useful for this particular case. Because in this case, the challenge is not to necessarily figure out the shape of it, but rather to encode that in such a way that it reflects reality as we want within the constructs that we have within this. Windows Calculate can actually do the same. Really? What the fuck? Holy shit, you're right. What the fuck? I mean, it still doesn't really help, but like, damn, this is a cool thing to like learn. How'd you know this? What the fuck? Wait, they have a lot actually. Date calculation. Huh. Programmer. Oh, for like hex? Wait, this is amazing. Yeah, because usually I just go to Google and I type like, what is this in like hex? You use it a few times. Good find. Good find. Thank you. Thank you for giving this. Okay, now give your temperature in Fahrenheit or Celsius, and I'll give you the opposite. That's it. 0 Fahrenheit is -17 Celsius a week. Americans a week. 36 degrees Fahrenheit. It's 2 degrees Celsius a week. I'm just kidding. A week. There's no challenge here. That's nothing to me. I'm a Canadian, and then it's like I'm like found frozen, solid. So we have the melting rate. Threshold. We need a threshold for when this thing disappears. So threshold. There's a threshold for deletion, right? This threshold is going to be some percentage of the mass. Or like some, I guess maybe even like a hard-coded value of mass, right? So hard-coded mass value. Well, I mean configurable technically, but configurable mass value. Mass value. Notably, must be smaller than default snowball mass. The reason is this. When you pack a snowball in the game and then you drop it on the floor, if it was set to the same or very close to it, it would immediately disappear and you would have no time as a player to like do anything with it. So you need actually some time to like play with it. It needs to be even smaller than what a default snowball is, which is fine because the rate of change grows over time to like a very large value. To where the snowball will basically disappear in like a couple seconds anyways. At this rate, I can actually model this. This may take like a good like 5 minutes. But after 5 minutes, I think the snowball will just disappear naturally based on this value and depending on what the threshold is. So it's not that bad. I think that works. But you see the problem, right? These two are diametrically opposed. Is that the word? Is that the phrase? Do I sound smart? Let's see. Yeah, completely different. Say diametrically opposed. God, I'm such a fucking genius. So they're diametrically opposed. One is about moving. One must be moving. The other must be still, right? And so we kind of need a way to ensure that both states don't happen at the same time. Effectively, we need an SSM, a snowball state machine. Fuck. 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 Okay, well, it's fine. Complexity grows. Complexity grows to match the needs of your program. Complexity will always grow to match the needs of your program. And at some point, you need to just figure it out, right? We'll do it like that. So let's say, okay, when it's stuck. What happens when it's stuck? Well, when it can't grow. Now we get into a bit of a sticky situation. Because usually, state machines are very simple to model when everything has no dependency on each other than exclusivity. State machines are simple when exclusivity is the only condition for one state to be valid at any given moment. State machines become complex when exclusivity is not the only one. And actually, they become incredibly complex when another state is the condition for another state and exclusivity. This state is exclusive. Well, not really exclusive. This state is inclusive of melting, so you can be stuck and also melt. And really, that's kind of a strategy then, because then it's like if it's stuck, you can wait a bit for it to melt and then push it even further. Yet exclusive of growing, because this is when it can't grow anymore. Oh god. On top of that, the snowball must have been growing beforehand. So, pre-condition is that it must have been growing initially. This is why it's a bit complicated to model this, and why the way that the code is now is so messy, right? The way I've encoded the state machine, it combines way too many different things together. When each of these are their own sort of like thing to manage on the snowball, and then this on its own is a complexity of in and of itself, because it's only inclusive of one tree of the state machine, but it is also exclusive of another, and it must have been growing before to get here. It's those. It's the ray trace logic, right? We have the logic here. After like 3 seconds, if it's still stuck, and the player keeps trying to grow, so this is really the condition is this. Cheap viewers on Twitch TV. The condition is this. The condition is this. Attempting to grow, right? Attempting to grow. No room to grow. So this is what the ray traces are for. So we have the ray traces. That's really the hard part. Now we just need to model this properly so that the code isn't very confusing. No room to grow. And really, that's it. So attempting to grow can be defined by the conditions over here, which is you're moving for a set time, right? Or rather that you're moving at all for like so moving for a set time for at least 1 second, right? Which is easy. You just reuse the condition over here. But then it also must be that there's no room to grow, which is the ray tracing. So in a way, this condition is shared among these two. So these are sort of two of the same, right? Oh god. But this should help us guide what we're trying to do, and this should make sense. After I get some coffee, I'll be right back in just a moment. Sorry about that. That took a bit longer than expected. You like this music? Good. I'm glad that you like this music. The goal of this music today is to really put you to sleep. This is actually the Animal Crossing OST at the moment. I think it's like the 7 p.m. or something. It feels a bit like rushed. It's a fascinating song too, because the song plays at 7 p.m. The day in the game ends around 8. That's when everything really closes up. And then it's kind of like that rush to get things done. But then it has that melancholy to it too. That song is fascinating because of that melancholy. That realization that no matter how fast you go, maybe sometimes it's a bit too late. But then it's also that hopefulness of like, it's okay. It's that comforting warmth of like, it's okay. Even if it's too late today, you always have tomorrow. And it's important to remember. And that's actually a great lesson that the Animal Crossing games have teach you, is that there's always a tomorrow. And there's always a next time. No need to worry about it too much. Don't push yourself to the limits for what? To save like 5 minutes. Doesn't really matter. Take care of yourself, because you're in a longer journey called life. Anyways, I'm going to follow and invoke Yagni here. The code word or the rune word Yagni. Y-A-G-N-I. I'm not going to need it. I don't need a state machine, because I'm going to follow my own variation of that rule for state machines that I've owned over many years of working with state machines. Unless there are 5 exclusive states, with many other things dependent on those states. Let's say at least two things that depend on each of the 5 states. Or if there are at least 2 states that depend on conditions of other states that are substates of other states, I'm not going to make a state machine. This is still fine to encode within the conditions themselves, but we just know in our head that it's effectively a state machine to us. If we happen to make a state machine, fine. But I'm not going to force it into a state machine if I don't need it. So let's pick this up. Now, the first step to any good piece of code is actually deleting code. For you see, writing code is about deleting code. Writing code is about simplification. Simplification implies that you need to remove and forget what isn't important. Because if we're going to change it anyways and it doesn't fit our purposes, what's the point of keeping it around? To muddle the waters and to confuse us, effectively. The best code that I've ever written has been a long deletion of code. Sure, it broke production, but my contract was over. Does it really matter to me? No. That was my best work yet. Probably my most impactful work. Instead, we start from the beginning of what we have, and we rethink all of these very confusing, very fascinatingly written variables and models, things that don't really make sense for what we're doing today, right now. Please enjoy as I break the entire system from the ground up. Plowable. What's the point of a plowable? Wait. Plowable.mass. New mass equals that. New mass. I never assigned the new mass. New scale. It's new scale, but I never assigned the mass. Well, I did before. It's actually a part of the movement. Okay, so I'm going to assign that at that point. Last frame position is very important for everything that we need. Death threshold is very weird to say, but I think it is perfectly good. New scale. Yeah, we just keep on going news, and we keep on trying to make more new things. At some point, the code will fix itself, and it'll figure it out on its own. Again, no need to worry about it. The you of today doesn't need to care about it. That's for the you of tomorrow. You of next week. The you at your new job, not as a programmer. That's whatever else is as far away as you can from the industry that you're in, so that no one finds out where you are, and so they don't stick the lawyers on you. Again, as we said, it must be still for a set amount of time. So we have something for the melt time threshold and the grow time threshold. We'll set these immediately to some number. I like NEN because NEN tends to be very nice. Death threshold is interesting because this feels like more of a mass thing than it really does a time thing. And so maybe we just say, like, what is this? Death mass threshold. That's probably a better name for it. Delta time last movement, delta time spent moving. These are very interesting because delta time last movement is really the thing that you really care about. But also delta time, because effectively time spent moving is the inverse of last moving, of like when you last moved, right? So delta time from when you last moved, we can probably reuse this for both. This, staying still, so it must be greater than 30 for staying still. Or this must be moving for at least 1 second, so this must never be greater than 1. The meaning of this will change, obviously, depending on the estate, but we now know what the states are, and I'm probably just going to do it like this. So we also don't even need the idea of like a can melt or a can grow. Realistically, as long as it's in your hand, it shouldn't be able to grow. Same with the melting. So this is only really viable for when you need to throw a snowball. Well, not viable. This is only really necessary for when you need to throw a snowball, which should only happen once. So maybe we can even forgo this. Let's see. Let me think about this. I put too much condensed milk in my coffee. It's 99% sugar. My life is over. The thing that worries me about this thing is that maybe I can encode it by simply turning off updates. But if I turn off updates, right? Me turning off updates is effectively the same as I would want to say modifying the internals of the system. Updates, and I think divorcing the idea of updates from our business logic is important. Because an update is what happens every single tick. Versus our business logic is it's melting, growing, stuff like that. So maybe we keep these. Because what I was thinking was we instead make it so that it doesn't update anymore. But that doesn't really make sense. Let's just do, I don't know, state. I know I said I wouldn't do like a state machine, but like it's too late for this. So growing. Do people do like this? Melting. What's the naming scheme for this? Oh. What? Does the engine optimize this as like I'm trying to think of something. What's replicated? Because we need to think about the networking model too. what do we need to replicate here? All of this ultimately affects the scale of the thing. So maybe as a networked player, all you really need to care about is the scale. But when it does transfer ownership, you do need to effectively give those values over. Or rather, really, I'd want to move towards like a server authoritative model where only the host has everything. Because then it's a lot easier to sort of model and change when you want to go towards host only. But that's sort of a matter of updating the annotations. So maybe it's fine. It's just a matter of updating the annotations. And because it's all based on the scale of the thing anyways, the scale gets replicated very easily because it's a part of the transform, which gets replicated. So there's actually no need to replicate any of this except for the Fidia scale. So growing, melting, or stuck. Or I guess really, even these two could be codified as something even like a fourth state. Because I kind of didn't realize this, but a snowball is not just a snowball on the floor. It's also a snowball that you throw. Or rather, we need to think about this even further. Why does this need to apply to a snowball that's thrown? Right? Think about this. What does it matter to a snowball that's thrown when it's not even a snowball that you can roll? Realistically, these are two separate concerns. One's a throwable item, the other is more of an entity in the world that simply exists. So even this idea of can melt and can grow is not really valid. The truth is, it's always going to be these three. And the idea of a snowball that the player can throw, visually, we can have it be the player dropping the snowball. But functionally, it can be its own separate entity, or even like its own set of components that are applied to an entity, right? I think that's a better way of doing it. Effectively, a prefab applied with extra stuff, or like a different prefab entirely, that we simply swap out at runtime to be basically seamless when you do drop it on the floor. Plowable is for because this is a plowable snowball, right? We need the mass from it. Last frame position, delta time threshold, delta time last movement. Is melting, is growing, is stuck. These are now codified in that state up there, which is easier, I guess. I don't really know if it's easier, TBH. But you know what? Programming is about attempting. It's about trying. It's about effort. Applied to your mind, to the world around you. To make something. To define something that goes beyond you and I. I say in the meeting room with my boss as he tries to get an explanation for why my stuff still isn't done after like two months. Mod, if you're here, you're gonna love that joke. Actually, she's at work, I think, or she's out. I'm not sure. I think she's out. I'm actually not sure. Anti-roids? What the fuck is this? Huh? Uh-huh. 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 Maybe we don't even need these. Door stuck time pass, we kind of do. Because delta time last movement must be above a threshold plus whatever it is, right? It's like if we encode it as a delta time last movement, it'd be kind of annoying to have to do the math to collate, okay, when is it above a value plus above another value? Because when you're stuck, it's actually a function of like if you try to grow. Whereas having its own thing, own number could be easier to manage in a sense. What was delta time passed for? I guess technically this was for the growth rate, right? We had some semblance of the implementation of the growth rate before, but not to a degree that's simpler like this, but also as complex as this. It's simple in terms of the things it uses, but it's complex in the ways that it works, which I think is a fine level of complexity to have. And I think we still need that on some level. But as to how we do that, I'm not really sure. Maybe this will always tick down. Is there a limit to floating point values? I guess it's just whatever 64-bit value you have. And if it's allocated as a 64-bit value, it should be very fast to update. So it doesn't even matter. Yeah, okay, it's fine. This will do a separate controller. A whole new controller for snowball movement. I'll write my own like code for it too, like the actual like collision code. I'm realizing that the collision code and the unstuck logic, it's built currently as a very generic pop on whichever side you're most on. When really you always want to pop towards the spot with the most empty space. which is almost always up, right? So it probably is better to do it like that for the unstuck for this particular game. And then we can think of a more complex model for like a different type of game once we get there, right? Build for the game that you have, not for the game that you want to have. Because either way, it's not going to be released. uh, he jests, but really his life it's all the same. Aware, he jests, but it's true though. Such is life. Uh, hmm. What's the default state? I guess by default, you're always like melting. Like as soon as you spawn, you're already melting. I melted. And then, yep. What are you talking about, eh? Is it better to use NAN or is it better to use 0? Like, is there any benefit to using NAN? NAN feels like a modeling problem or like a modeling value. Like NAN feels like a very domain-specific modeling value that you use to model some form or some state or some value or some system that has the ability of like a number that might not exist or a number that wouldn't make sense, right? Where 0 is like, that's really it. But also, I guess it works out here because it's like you have to have a number. If there's no number, like it can be 0. It can be 0, but that's not what you want. Basically, the domain is this. The domain of this sort of like thing here is this. It can be 0, but 0 is just as valid as like 69, right? Or 420. They're all perfectly valid numbers. And so really what you want to communicate to the person using this, aka me in the future, is that NAN is a default value that means you should set it to like something. You're the senior, you tell us. You know, seniority is actually defined in the funniest ways. I find seniority to be defined in the strangest ways. Seniority to me has always meant nothing. Never meant a single thing at all. One status and tenure has never meant anything to me because it doesn't mean anything. You could be the most senior person ever. You could be at it for years, decades even, and you still might be no better off than somebody who like just started. I tend to find it's better to model it as a mindset thing. The problem is that how do you model a mindset? How do you model a character? How do you model a person and all of their complexity within a stat that can show up on a sheet on your resume, right? We happen to choose years of experience because it's like the one thing that is the most fair because we all experience time at the same rate. But the truth is, it doesn't really matter which way. Truth is, what makes you senior is almost your mindset. Not to say that like when you're old, you're not feeling old, but in the sense of like when you're old, and only when you're old is when you start to feel old. Is when you start to act old. Is when the oldness takes you over. Maybe I don't know. Maybe I'm just like maybe just I don't know what the fuck is going on. Why are you taking life advice from me? I don't know shit. I don't need system. I had a feeling that was in. Yeah, okay, so we do this, we do that. That can be 0. Because 0 is like this, because it's a struct. It has to be 0. There's no other option. The problem is that if last frame position is also 0, this will break. If you're at origin, if we build everything around origin, and the snowball gets to origin, and it sits at origin, it'll always be seen as staying still. Or if you move around origin and you only move around origin, it'll always be seen as being still. Really? That's fine, because movement is change, and you would see change, because the current position is not 0. If it was 0, yeah, it's fine. It's whatever. The modeling works. I think this actually makes sense. Okay, now we need to deal with this. The is proxies were for the networking model. Right, these are for the networking model. This also actually needs a is a proxy too. Yeah, let's go like I don't know, like here. There we go. Yeah, good. Yeah. Here we need to do everything. So actually, there's okay. So really, there's like 3 different functions. So like is, if, current state. I mean, it's really a switch statement. I mean, switch. Why does it do autocomplete stuff? God, if current state case, state that growing, break. Can I have this fill out like every single case actually? Oh, there we go. Nice. And default. Default. Yeah, just throw an exception. Look, because that should never happen. Or rather, default to melting. Worst case, snowballs just melt away. They won't grow into infinity, nor will they disappear by being stuck. Well, you know what? Being stuck is probably the best default state to be in. Because that gives you like a huge indicator, right? It should never happen. Logically, it should never happen. But it is what it is. So actually, don't even throw here. I mean, do this, but there we go. Yep. Now, what do each of these do? I don't know. Step bro, right? Step bro. No need to even check. We just hope that the state machine covers it all. We hope that it covers it all. And then we also do so we can just focus on purely the growing aspect and like the melting aspects. And really, this now needs to deal with. I mean, yeah, let's just scaffold this before it grow. We'll just scaffold a function and we'll just figure out what this like goes afterwards. Is it even worth to scaffold a function? Yes, because switch statements, having more statements in a switch statement is like it's like a hell. That's like a fresh hell. It's like YAML hell. Where is it? This one. What was it again? What was growing again? Must be moving for at least 1 second, and it must be mass. Then gets added to mass times terror rates. In this, actually, scale by mass should always be running. Well, it should be scale by mass, and then like it should be grow and then scale by mass, because these do 2 very different things. One scales by the mass, one does something else. Is proxy return? All right. True. Well. Is it necessary to check the is proxy in every single child function? No. The children don't care. The children can just live their lives without a single care in the entire world. Children should be free. What really needs to know about the school schedule is the parent. The parent, where we call these, that's what has to know if it's a proxy or not. Yeah. Okay, so now we need to figure out this. Well, how does it grow? Well, this increases the scale by a what? I'm moving this to monitor 2 because I can't see this, okay? You can't see it now, but I can see it. This is a me thing. This whole experience is for me and not for you, technically. So you know what? Does it really matter if you can't see it? No. Daddy's time on the computer. It's my time. Must be moving for at least 1 second. So if delta time, last movement, not equal or like less than 1. Or like grow time threshold. These names are confusing. These names are very confusing. Grow time spent moving threshold. Melt time spent still threshold. Then we model this with delta time since last movement. Let's just be as verbose as we can. I'm gonna forget what these mean tomorrow. Like I'm not even kidding you, chat. I'm gonna forget what these mean. Because there'll be time even while I'm off work. Or like sorry, not off work. I'm spending time with my wife. She's not work. She's my joy, actually. But, you know, me and my wife, we have like very different sleep schedules. So at some point, I'll just be like programming with my like dog on my desk. What's sad is that you never get to see my dog on my desk. Because she's mostly at my mother-in-law's place. So you never actually get to like see her like just hang out. Because usually when I program like off stream, she's on my desk and I have my left hand on her, like petting her and like holding her. Because she hugs my hand because she really like she's so cuddly. She's so funny. 10 weeks later, what is step bro? Yeah, exactly. Yeah, it's like, what does this mean? Why did I do this years ago? What was this for? There we go. Now it's at the symbol. There we go. Door stuck, time passed. Shelter, time spent stuck. We're changing these names now. Sorry, chat. There are two hard problems in computer science. Naming things, caching, and off by one errors. What's the name? Sad face. Sad face. Please don't kill Step Bro. Sad face. Step Bro is going to die, chat. You can't sad face me out of killing Step Bro. I feel your pain. Like, I know the words that you're saying. Like, please don't do that to Step Bro. Please don't. Step Bro needs to go, okay? It's time for him to move out. He's like 18. He's an adult now. He needs to take care of himself. He's not even like, your father's real son. So, like, does he really care about him? No. Like, he has to go out there, earn his own money because, listen, when your new dad started dating your mom, he was like, look, sure, fine, I'll take care of him. But as soon as he's 18, he has to leave here, okay? And your mom agreed. So Step Bro has to leave the house. The hell do we call him? Determine stuckness. Determine stickiness? Determine stickiness. Yeah, fuck it. We'll just... Cool. Now you gotta type that as a comment, else I will be sad. It's sad, isn't it? Your new father said that he'd only take care of you because he wanted that thing from your mama, son. To him, you were always a burden. As soon as you turned 6, you lost your real father. Then at 13, you thought you learned what disappointment was. Then at 13, you lost the hope that you'd ever have a family again when your stepfather entered the picture. Now, at 18, you've lost the only home you've ever known. Thrown to the streets to fight for your life, to suffer. To seethe in anger at the circumstances that you never wanted for yourself, but that were thrust on you before you could even learn to say no. Now you must grow from this and become stronger to one day come back to the family and take back the throne that is rightfully yours. Brian's head will roll. I don't know why the stepfather's named Brian. Sorry. Getting too real. I just told you my like life story, and like I'm making a joke out of it, but like inside I'm just like angry. But now I'm happy because I'm making money or something. And you have no clue. You'd have no clue. You'd have absolutely no clue that this success is simply a matter of trying to make the best out of a world that didn't want me in the end. Aware. Oh, oh, what the fuck? Oh shit! I didn't know you could do that. Okay, this makes sense. So if other time says less than grow time spent moving threshold, we simply say return. It hasn't moved. It hasn't spent time long enough not moving. So this actually does something that's shared by all. The time since last movement is kind of the thing that's shared between everything, right? This will grow over time, and I think we just cap this at some value because otherwise it gets stupid trying to track it at some point, right? Like if you keep growing more and more and more, you eventually overflow just because of time, right? Next person that looks at this code will see something special and write a book about this. Really, you could say that about all of my streams, right? I think anybody watching my streams, you have like enough material to fill your Wattpad up, right? Honestly, if it wasn't for programming, my other actually career choice was to be a fan fiction writer because I heard that they make a lot of money. So I was like, I'm just gonna write like fan fiction. It's why my writing feels very like weirdly weirdly fan fiction. I spent a long time learning how to like write fan fiction that was appealing in like a very stupid way. Because fan fiction, right? It's appealing in a very stupid way. So, hey, if you need a writer for your stuff, hit me up. I got you. So now we see it based on whatever the current position is. So let's say we take the position, transform position like this. Here, every single one of these depends on the delta time since last movement. So if we're currently moving, the delta time, like if we're not moving, so the last frame position is the same as the current frame position, then we simply say, okay, well, they haven't really moved yet, right? And really, even on start, on awake, what's the life cycles? We're going to open the documentation for the first time today. We're getting better at this, right? It's a good sign that we're understanding more and more of it because it means that we're actually understanding what this is. By the way, I should have maybe started with this. I think the game jam is fully done. They took up the game jam link. But I think they're still deciding the winners, but they learned something. So, first off, errors and exceptions are very interesting. They're thinking about a way to do this at some point to make it very, very real. And right now, errors are kind of like propagated down into games. So, for instance, when you go into the console of like when you're playing a sandbox game, you see an error that doesn't really make sense. They're going to eventually enforce it so that if there's any error, they just immediately disconnect from your game, which I think is good because you don't know what code-wise, you don't know what the extent of the error is. It's very hard to know, for instance, is this error a safe error that can be ignored and thus the programmer is correct? Or is it a bad error that will cause the system to like crash? Like you're spawning like a million different things and you're about to exhaust like your VRAM, right? Like you don't really know. So what they're going to try to do is make it so that you're forced to deal with the errors themselves, which I think is the right thing to do. They have a new human rig model. Rest in peace, Terry. Rest in peace. I've loved you, Terry. No one else loved you, but I did. Why does it say disconnected from the website? What? Anyways, there's a human rig model. This, I don't know. You're just not the same as Terry. You're just not the same as Terry. Anyways, so they have that. There's a new menu layout, apparently, which is pretty interesting. Feels like an actual proper game library, because again, it is meant to be... Sandbox really is, again, modeling... Basically, Sandbox, the thing that feels interesting about Sandbox is that it feels a bit like Steam itself. it feels like a re-implementation of Steam, but with the added benefit of you have the main server that like does you have your matchmaking server built in, as well as a server host. Effectively, s&box to them is a hosting service as well as a matchmaking service, which is a lot to handle all in one, but they're trying to make it work. Streaming worlds are slowly coming into view. Currently, a bit of a like work in progress, but they have a review of how it kind of works here. From the team, and we'll see how this sort of goes. It's mainly as a library for now, and it's like mostly using some of the things to make infinite like editable terrain and stuff, but it's pretty cool as is. There's voxels. They're trying to get this as like built-in support. They finally fixed the stats to not require like, because I was looking at stats and I was like, you have to define a lot on the back end. Now stats are whatever you want to record, so could be interesting even for like pulling back in data. Like maybe you could do that and sequester. You could theoretically Trojan horse like any data that you want here. Actually, I won't do that. Maybe, but there is a possibility here to write like a save load thing, which I don't know if you should, but I don't know. The leaderboards also no longer need to be defined, so stats are different from that, which is fine. They tried to build like a voxel survival game on the Hack Week. They tried to remake SFM inside. This was actually what I was going to do too, because I recognized this was like, why do a cutscene in SFM and you have to redo all the other effects? Like if your game has like a snow effect, you need to then copy it to SFM. It's easier if it's integrated into the engine itself. But instead of integrating SFM, they made their own thing. So I don't really know what it means. Better instance drawing, a beta of standalone exporting primarily to show Valve how it's going to work and if they like it. There's a state machine editor, which actually is pretty interesting. But it's just its own library for now, and I don't know how to use these. And I don't really need this yet. Again, it's like you don't really need a state machine until you have like 5 states. Like actually this shows this very perfectly. You only need a state machine if there's at least 5 exclusive states. Or if there's at least 2 states that depend on another state, which is this. So basically, do you have a graph or do you have a tree? If you don't have either, then you don't need a state machine. But as soon as you have either, you're going to need it. Keep that in mind, because you're going to reach for a state machine a lot. You're going to think, yes, I learned about state machines. This can work as a state machine. And you realize very quickly that the code to manage a state machine ends up being more complicated. So you need to like trust yourself. You need to tell yourself, no, not yet, not yet, not yet. Then when you need it, you maximize value and minimize the amount of like code work that you need to like do to support that. I do need a C# state machine. What's that thing called again? Like, what's the thing that allows them to like do stuff like pull in libraries? Because theoretically, if it's C#, you just pull in any library you want, right? What's the thing called? NuGet packages. State machine. Accelerate. Okay, let's not use this. Yeah, let's not use that. Let's just ignore that then. Let's just ignore that. I have nothing against accelerate. I have everything against accelerate. Yeah. Let's ignore that. Let's actually like implement this stuff now. But first I need to know the component life cycles. There we go. Is it these ones? Here we go. Because what I want to do is on the start of the thing, I need to track what the current position is as its last frame position. Because it's not a null value. So it has any value. It has a 0 value. A 0 value is sort of my way of saying this is not a valid value. But a 0 value also can't be used for anything meaningful. Ideally, I want the value to be like actually the current position as soon as it starts gameplay and spawns into the world. So this is when it gets enabled for the first time. Gets called before on fixed update. The order is roughly the same. The order roughly makes sense. There may be steps in between, but ideally this is the thing that says when it's ready in the world to use. So we do on start. Need to do this quickly. On start. On start. There we go. We do last frame position equals transform the position. Then this logic only works. Then this logic will only have to deal with any changes, which is great. So if it's the same as the current position, we just add whatever the delta time is. Wait. Otherwise, we say delta time since last movement equals 0. So now it's moving, and now that is no longer a thing. And then we see what needs to be done here. Now there's a lot of different conditions, right? Like you need to see if grow time, spent moving, stuff like this and that. Realistically, what you kind of want to do is it's not really important for the grow thing, for the growing. Like the growing is its own thing, right? So really, maybe we just check it here. Code-wise, it feels like it makes sense over here, but I don't know. Somebody will look at this and then be like, "Oh, this streamer doesn't know anything about programming. This guy's dog shit." Like, and you're not wrong. You're not wrong. So if delta time spent less since last moving, delta time spent moving. We need time spent moving. Aha. So there's two state machines. There's one for time and one for the movement. Fuck. Because we need time spent moving and not moving. Time spent stuck is kind of its own thing too. Maybe it's a good thing that we moved everything upwards to deal with it here. Okay, good. Well, now that the time is spent sort of like moving, so let's say time grow time spent moving threshold. So delta time spent moving plus equals 0 here. Okay, so whatever we again see, if you don't need a state machine, you just do if else statements. It's really the same thing under the hood anyway, so like doesn't really matter. Plus equal time to delta. Yeah. Or we only care about it in these. How about this? But I need to know by the conditions. I need to know if the conditions are there. But then we can not do this if we don't need to. Yeah, no, this makes sense. Okay, so if delta time spent moving is less than the grow time spent moving threshold, then we just return. We don't do anything. Otherwise, if it is supposed to grow, well, no. Well, yes. And then this would determine what the state is. Effectively, this would determine what the current state is. So like this determines the state, that stuff determines what it does. So if it's moving, we know that it's moving. So it's really, I mean, the start of this is that it's moving. The start of this is that it's that, start is that. Really? Really? Do I want that to be its own state, or do I want to just check by the movement? Like, do I want to do like this? So if it's moving, it's like moving, and then it changes to growing. But then how do you know that one is dependent on the other? You need a state machine. The only way to know if one's dependent on the other is because that you need a state machine that maps everything else. So let's just ignore all of that. We don't need any of that. We don't need any of that. Okay, so we know it's moving. We know it's moving. What does that mean? We just update this like manually, and we just do everything here. If it is at that point, then we do the grow. So the grow doesn't need to care. This handles time. This handles space. This handles time. This handles space. So let's split like this. How do you handle like stuckness? When do you handle like stuckness? If current state equals state that's stuck, and we're also still in the same place. No. Some time is spent at the top level. Other time is spent at the bottom level. Yes. Because then it's like, okay, let's say you are staying still. Delta time since last movement. Well, I mean, delta time spent melting. Wait, no. So it's only spent moving that really matters. It's only this case that really has that special case. That's kind of weird. I don't know. Fuck it. We grow. I'll figure this out. My brain's kind of mush after today, so we'll figure it out. Yeah, then we melt. Yeah, then we melt. Yeah. That idea join. What? How about no? Okay. I'm liquid. I'm liquid. From here, while it's still going, we say delta time spent melting. If delta time since last movement is greater than... How the fuck does this even determine what state it's currently in? You know what I mean? Like, how does it even know what state it's in? It's like this has a determined state beforehand. Well, it's nice to see it. Maybe send the property so we can see it. And what we do is this. So if it's moving, then we know it should be melting or growing. So if it's not moving, it should be melting. So current state equals state dot melting. If it's not moving, it should be melting. If it's moving, current state equals state dot growing. But only if it's not stuck. Well, stuck is its whole thing. Because stuck is a different thing. Maybe I'm modeling this wrong. Stuck is really its own thing. How about this? Right? Then this. Right? Then if this. This. Right? Well, either way, you do this whether you're growing or you're melting. If. Right? And then. Right? This is stupid. There we go. There we go. Then here, we do if delta time since last movement. Yeah, and then if last frame position the almost equal transform dot position. Delta time since last movement plus equal time dot delta. Yeah. Else delta time. Really, delta time since last movement is not a good way of saying it. These are the values I need to track. But the values I need to track really depend on a whole different structure. Fuck it. Whatever. Since last movement equals 0. Yep. And then this here. Okay, let me just do this. So for it to be melting, it must be staying still for at least, what, 3 seconds, right? What did I say? What did I say? Must be still for at least 3 seconds. I mean, it's really the threshold. Yeah, okay. Now I remember what I did. Sorry. The coffee's wearing off, so I don't know. What is it emote? The egg? I cooking. Let me cook. Let the caveman cook. Let the caveman cook, chat. Let the caveman cook, okay? I'm an old man now. My brain doesn't work as it used to. When I was younger, when I was younger, I could cook this out in like 20 minutes. Now that I'm older and I'm also like really tired, I'm still actually really tired from like work from before. Um, my body doesn't want to do anything. Game should have been submitted end of day yesterday, but get it to my desk ASAP. Thumbs up emoji. Yes, boss. Okay, boss. I'll get it to you. By the way, boss, can you read the story? By the way, while I was coding, I thought of a new story. So I know we're making games, but like, how about we pivot into fan fiction? Okay. It's sad, isn't it? Your new father said that he'd only take care of you because he wanted that thing from your mama, son. To him, you were always a burden. As soon as you turned 6, you lost your real father. Then at 13, you lost the hope that you'd ever have a family again when your stepfather entered the picture. Now at 18, you've lost the only other home you've ever known. Thrown to the streets to fight for your life, to suffer, to seethe in anger at the circumstances that you never wanted for yourself, but that were thrust on you before you could ever learn to say no. Now, you must. You must grow from this and become stronger to one day come back to the family and take back the throne that is rightfully yours. Brian's, stepfather's, head will roll. Hidden stories in the code, yeah. It's like like that the YouTube channel, Every Frame a Painting. Instead of every frame a painting, it's every function a story. Every function a story. My soul. So if it's greater than the melt time threshold, then we start to melt, okay? Then we say time delta time spent melting plus equal time dot delta. Otherwise, we simply return and we say delta time spent melting. This is way easier. What was I thinking before trying to handle time as its own thing? Time? You think you can manage time? You can't manage time. Time is its own thing. Time exists in its own thing. The funny part is that you think he's joking. I've just like told you guys my life story, but it's like, but I'm afraid to be vulnerable with you, so I've decided to like laugh at it instead of like making you feel uncomfortable. Because as I was opening up to you, I like saw your face start to twist into a face of like pity and like pain, and I felt like I never wanted to be pitied ever again. So then I started laughing to like turn it into a joke, like a sick joke, as I found like edgy. But really, all of my edges had been worn off by the trials and like tribulations of like time until I'm simply a smooth stone, simply washed away by the oceans of life, by the tides of time, weathered away down into sand that simply dissipates in the winds. Yeah. No way I did that. So if delta time since last movement equal hmm almost equal to 0. What? Well, oh, you can just do that. Almost equal. Yeah, you can just do that. You can just do like 0. All right, cool. So if it's almost equal to 0, then we know that it's moving, right? Then we can say, okay, well, delta time spent moving. Yeah, this is way easier. This is why I I did this. Fuck you, Brian. I am doing something good with my life. I'm just kidding. Delta time spent moving. By the way, I want you all to know my mod tried to extort me. Our mod tried to extort me today. I want you to know that. I want that to be known. Because when I disappear tomorrow for speaking out against my boss, I want you to know that the boss had me turned inside out. Like a fish. Gutted like a fish. I'll gut you like a fish. I'll cut you down like a fish. You're nothing to me. You're but a fish. You're a fish. I'm a fish. I'm a fish. Nice. If we've been moving for at least 1 second, for whatever the threshold is, well, if we're still below that value, then we simply say we do nothing. Otherwise, we start to do things, right? So now we start to do our logic, which is this. This one, where we start to grow. We grow by increasing the mass, and then scale by mass handles everything. Again, melting is really the mass equals melt rate divided by mass equals effective melt rate. So it's kind of like this. It's kind of like this. Oh, oh, this song is so dramatic. I'm gonna cause an error. Okay, watch. I'm gonna cause an error. No, but where are they? Where is stuck? I I thought they were here the whole time. Where could they have gone? I I thought they were still with me. No. When did you leave me? When did you disappear from my life? What's funny is that the VOD viewers, they don't hear this music. So they probably think I'm like going through like an episode, but it's like if you heard the music, it's really sad. That's what you miss out when you're live. Context. You miss out context, opportunity to interact. You miss out an understanding of the greater picture. When you watch a VOD, you get cucked by the passage of time and DMCA. I want you to know that. Now watch. The magic of pseudocode. You simply type, and the answers appear in your mind. The hell is a steroid? No music is the real context. It's just like madness. It's just like madness that I'm going through at the moment. So we only update the last frame position at the very end, so that people can work off of the difference, right? In fact, each of these should maybe include like a difference, or rather like a difference. Yeah, it's like Zack Snyder's Justice League. Wait, actually true though. Wait, you're kind of right though, right? With the color correction too. So it's like both the color correction plus the no music, or like the color correction is the music. I see what you mean. I'm picking up what you're putting down in my chat. Sacrilegious. Distance moved. We just pre-calc this for it, and it can do it here. Because then it affords us some things. Like we might do this first, even. Well, does it really matter? Nah, fuck it. We'll do it at the end. Doesn't matter. Because in the end, does it really matter? No. Although what does matter is that it's now. So the problem with doing it like this, right? This is actually something to be wary of, and I think about this now. It makes sense not to do it like this. Right now, the what grow does depends on what this does. Right? It depends on like delta times since less movement. It depends on a lot of like different values that it needs to know about. But it's like, does that really make sense for it? Not really. For instance, even the fact that it needs to know how to calculate the current and the last frame position, it needs to know about this like interaction here. And this function also, like the function that calls it, also needs to know not to modify states until after grow has done its own thing. It's why I don't like state in general, because it's hard to sort of manage those relationships, right? It's why in general I like to make code as functional as you can. Why I don't like having state. I say as my state variables in this in this class are like it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's like 12 or 13 state variables. But the thing I'm getting at, if I was smoking and I told you not to smoke, would you still smoke? No, that's because it's stupid, right? You wouldn't smoke. So same thing. Be explicit with all of your dependencies. It's more copies. It's more copies. I change it. I change everything. It's more copies. Distance. We now need distance. So we need distance, which is that's firmed up position minus last frame position. Oh well, what's the difference? How do you get the difference actually? Oh, oh, perfect, nice. Divided by the plowable plus mass. Boom. That's it. That's it. That's all you need, right? And like a multiplier. So growth multiplier. Is there like a well? That's cooler. You know what I mean? Is there no? Because NEN is only because floating point with the mantissa. Yeah, you know what I mean. So unsigned integers they can only be like positive, right? But signed can be negative. What's funny? What's cool about having it be signed is that you could have like a melting potion. You could have like a lava potion or something. Drop it on like a snowball. Like it because again, I do want some level of the interaction of the multiplayer to be fun or to be chaotic. Like I want the ability for people. I want to use the multiplayer of Sandbox to force people into situations where they must self moderate amongst themselves and their peers in order to get stuff done. I want them to work together in a system without having the system like hold them back. Sorry, give me 1 second. Because if the system just focuses on holding them back, then you're not really playing a game, are you? Right? You're trying to break out of a sandbox. And I don't want you to feel like you're in a sandbox. I want to use sandbox to make you feel like you're in a game. Now that's a marketing slogan. Fuck. Why I could be rich. Sorry, sleepers. Sorry. I think I woke all of you up. Sorry. My bad, bro. Melt time spent still threshold. We do nothing. If it hasn't reached that threshold yet, we do nothing. Otherwise, we reduce the mass. See that? Now we do. See that? Minus equals. What's the formula? Formulae. Ravioli. Give me the formuli. Mass. Minus equals. This. We didn't model the current melting rate. Property. Sorry, wrong property. No, please. Formioli. Stop autocorrecting the wrong thing. Private float melt rate equals float.nan at the moment. So while it's melting, while it's moving, while it's melting, it does melt rate plus equals over here. Like the melt rate really is modified over here as a separate thing because this really only deals with like delta time spent melting, and really they should be capped at some point. Like it should be capped. Like it. How do you cap a value? Because I don't want to run into an issue where you get to like the very limits of the value and then it rolls over, right? Because somebody could be playing this game forever and they're forever rolling a snowball. But doing that check is expensive. Well, not expensive, but it's like more logic than you need. Like that's the beauty of like undefined behavior. The beauty of undefined behavior and like known bugs that you just happen to let happen, and you just assume that the gameplay will that the player will like never make it happen, is that you get to reap performance benefits by way of not having to do extra things. Your code is simpler, and you have to deal with less. It's simpler because it's not your problem, it's the player's problem. It's a bit faster because there's no need to do a runtime check every single time you want to add a number to something. Like if I wanted to say, okay, well, add the value of time to delta, as long as delta time spent moving or spent melting is below the threshold, so we never go past like threshold just to make it so that you can't overflow. You would just do a clamp, but then the clamp has to check if it's over, say it's under, right? Or we just say if it's already over. Like either way, you have to check. So yeah, we just let the player deal with it. I'm gonna good luck, buddy. So if it's no longer hmm. Yes, yes, correct. Um, the delta time since last movement thing. How do I now reset? How do I make it know that it's like? How do I let it know that it's moving? You know what I mean? Because what I need to do now is I need to set the melt rate back to 0. So like where do I do this? And then where do I do melt rate? Because here is where the melt rate grows. So melt rate equals can you do ternaries? I actually don't know. Do you want to do a ternary? I don't know. Is that a crazy move? Maybe. Do I even like ternaries? Not really. I mean, kind of, technically. I mean, melt rate. It was it float.isNan melt rate. 0.01. And then complex logic here. So instead, when we do like if, you know what I mean? Like, because it's complex logic anyways. There's no need for us to like deal with that when we just do it like this. It has to be done anyways. Ternary is only really good when you only have. Ternaries are really good at return points because that's all you can really do, and there's nothing else after. Or if like both conditions are so simple, so as to be a selection between two simple states. But where ternaries start to fail is when either side gets very complex, and that's when it's like you save like the line of writing an if, but what you lose in like what you gain in like terseness of the if statements, you lose in terms of being able to manage the complexity because now your scoping is not done by the constructs of by the usual constructs of scoping within the language, which is like I guess in Python it doesn't really matter, but in C# and other similar languages, the braces, and you instead do it by a brace after a question mark or something. Like it just feels kind of confusing. Whereas an if statement is like very, very verbose, but also very clear. And it's either way, it's the same thing. So does it really matter? Yeah. No. Now the melt rate again has to kind of scale over time. So it has to lerp towards a value, basically. And it's like a percentage of the full value. Isn't there like a math.lerp actually? Scale. Huh. X? No, I don't want to do that. I also don't really want to do a math function because it's like it doesn't make sense. Maybe instead of lerping, we don't even do that. Maybe we just have it grow at a consistent rate. But then it is nice to have it grow at like a different rate per. Let me think about this. Does it really matter? Do I want it to ramp up? Do I want to define my own curve? You know what? Until we feel it, I don't know if it's gonna feel good anyways. So why even bother? Right? What's the cap? 10%. This is gonna be a hard-coded value. And then there's gonna be, if we need a modifier, we just do a melt rate modifier versus messing with the base melt rate. I think that makes more sense. Over 30 seconds. Plus equals 30 to 10. So what's the ratio? What's the value that I need? This isn't even like a thing. It's just I'm trying to find the actual like value that I have to get. It's well, 1 at 0. I mean 1 at 1 technically. 1% every 3 seconds. Oh. So 1% every 3 seconds. So it's delta time spent melting divided by 3. But it's also a percentage, so divided by 300. Yeah. Well, 300 divided by that, no? What's the value again? Is that 300 divided by... Let's say like delta time spent moving is like this. Because it's like in milliseconds, right? Well, it's in milliseconds. And it's every 3 seconds, so does it really matter? How much is it? How many milliseconds are in a second? That's really the question I should be asking. I can't remember. Is it 1,000 milliseconds in a second? Is it 1,000 or 100 in a second? 1,000. Yeah, okay. Because milli is 100. I always forget which one is which. It's honestly, it's all the different names for like value types is weird. Yeah, divided by 3,000. Yeah. Yeah, basically. And then math.clamp. Well, and then what's a clamp signature? What? I'm sorry. What is this mess? What? What is it? Okay, returns value clamps the inclusive range of min and max. First argument is value. Second one is min. Second one is max. Why does it elide the names? You know what I mean? Like why does it say byte by byte? Why does it not expand the name of the target itself? Because that's really what it means, is you need to name the parameter to know what it's used for. You can't just do it by type alone, especially for like math stuff. I'll add that to my to-do list. Fix IDE to show quick doc. I think it's called quick doc or something. Like Java doc, I don't know. Quick doc bar names. 1,000 milliseconds equals 1 second. 60 seconds equals 1 minute. But I remember I remember having that same thought, and then I looked it up. It's because of the rotations of the sun or something. Or like something about circles. It's specifically made to deal with circles. It's because it's honestly it's because of the Sumerians. The Sumerians like circles. However, other cultures use like I think base 12, which is a way easier number system that has everything line up, but then it doesn't fit well within a circle. I think that was exactly the reason why. Numerology, I think, has like a great video on this. Which is the channel name Numerologist or Numberphile? I remember reading the name once, and I was like, this feels like a very risky name. So maybe it is a Numberphile. I don't know, but that's basically the reason why. Well, maybe max. The larger of the two. So I do want to clamp. Yeah. Min max. Max is 0.1. 360 divided by 60 equals 6. 360 divided by 40 equals 9. Thus 69. What's crazy is that like I can see that joke being made. Like I can see Terrence Tao like going up to like a whiteboard, writing that like down in his first ever math class, and everyone starts like clapping. Like, let's go! That's a melt rate. Plus equals that. When it's clamped up, it's good. We only do this as well over there. So if melt rate less than 0.1 F, we then do this, and it'll clamp it there once it's done. If it's at 0.1 F, then we don't even need to bother. Then, well, maybe, yeah. Then we melt the snowball. We do the mass. So now the mass minus equals uh mass times the melt rate, right? I think that was it. Yeah. Yeah. Mass times melt rate. Neato. It's way easier to understand now. Like it feels like it flows a lot better. Like you know what each piece of code is doing. This one handles sort of like the figuring out which one to run. This one handles sort of the state machine as well as like the prerequisites for the state machine and setting up state to be what each and every single dependent expects. Every single thing itself handles exactly what it needs to do for its particular dealings with the mass. It's a bit annoying and complicated, but it also like makes it feel better in terms of the way it works when we actually get to the game. And then by the end of it all, the scale by mass is its own thing that handles its own self, that then manages whether or not it's doing its own thing. Like whether or not it needs to report back that it can't grow. Yeah, that's some good shit right there. Mm. That's some real good shit, man. Now the problem is how do you actually change the state? Like we do it anyways because it's like we just set it to the. Realistically, it doesn't even need to be a property, but I set it as a property, so it's easier for me to view, right? That could just be an inline variable here too, which is better for the flow because then I know. But I happen to do it as state because it's nice for me to like peer into it as a property for later. Yeah. So then what we do is we do this. So how do we determine the current state? How do we determine the current state? It's really this. Hmm. Hmm. Mm. Fuck it. Fuck it. Fuck it. Fuck it. Fuck it. Fuck it. Since moving, current state. Uh-huh. Huh. Well, yeah. Yeah. I have to. Because otherwise, how would I know to set the current state? That's kind of the issue. Yeah. 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 I also need to put this somewhere. Where does this go? When do you reset the melt rate? Hmm. I mean, these things are very complicated. Time is complicated. So time is complicated. Okay, so now we have to figure out this. It's really I need to set the state in somewhere. So all is equal. So while it's not moving, delta time since last movement equals this. Current state equals state dot melting. Else, current state equals state dot growing, but only if it's not stuck. Current state, oops, equals state dot stuck. State dot stuck. State dot growing. Well, I mean, really, that's kind of a stupid way of modeling it. It really should be modeled like this. You can tell my brain is really dead because like we had virility, we had life, but now I've had nothing in my brain. Yeah. 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 Perfect. That does everything. Okay, cool. And then this needs to know when to reset it. Like the problem is that it needs to know when to reset these like values. Hmm. What? Do I want to have these here? This doesn't really matter to it. These are really only a part of these. Eh? There we go. Okay, so we only care about this. That cares about the state. These are really specific to the thing itself, so doesn't really matter elsewhere. Yeah, yeah, okay, not selection basis. Sorry. You know what I mean, Chat? I know you know what I mean. Do you know why? You're all geniuses here, just like me. You and I, we're both throbbing. Actually, I've been throbbing ever since. I don't know. Sorry, didn't mean to cut the music. That's sorry. Don't worry, chat. It all makes sense. Like I don't think a state machine could ever help. Well, a state machine will actually help fix this. The problem is that the state machine doesn't really help fix this anyways because it's like, well, kind of. In a state machine, in like parlance, when you transition states, you need to do certain things. It's kind of like why state machines exist. Because state machines allow you to attach a lot of like different things that happen based on different conditions, specifically around when you enter a state, how you enter a state, from where to what, and all these other things. Like you actually get a lot of flexibility in applying logic that happens on the pathways and the transitions between states. That's really the value of a state machine. The value of checking what state you're currently in is kind of like neither here nor there. It's not really like a major deal. The majority value that you get from a state machine is like determining what happens when you transition to a state and like how that happens, like what the pathway looks like. At least from what I found, with like using them fairly extensively for similar problems. It's really nice to see the pathway of where you come, of like where you come from, and even like the way you come from. It's modeled by like the state can only be reached by the state. So all you really need to care about is like the transition of the states when it happens, which is nice. The entry point, effectively, which is this is what it's trying to do, but very poorly. I mean, state machines are kind of like the ultimate form of an action graph, right? Like an action graph is the best representation for a state machine. Because a state machine action graph is a visual sort of like scripting language side of it. And a state machine, when you visualize it, becomes much easier to see compared to the code wise. Because code wise, you're basically always looking at something like this. Well, the better model would be like something attached to like a callback on a transition, right? So a transition happens, some event happens. You then attach callbacks that like do things on those transitions. So when you enter the melting phase, for instance, you would do this logic. Wait, no. When you enter the melting phase, you would start this like running interval, this like running loop, right? When you leave the melting phase, you would do this once and stop this, right? That's sort of like how you would model it. It's like entry, exit, but then there's also dependencies between things that happen, within those things. Like exit needs to know to stop doing this. So this is like an entry plus while you're there, like a during. Okay. Makes sense. Makes sense. We'll do it later. We have, oh god, we have 15 minutes left. So the reason why I put a cap on every stream now is because I need to really have time to do the extra stuff that I want to do, like editing stuff and highlights and stuff. Because I honestly do plan to grow this to some degree. We won't lose the same vibe. I don't think we'll lose the same vibe. I think we'll always have that special place, especially in in the cinema. But by the way, tonight's cinema, like actual factual, 15 minutes cinema. Okay, while I eat, there's something that we have to watch. Don't talk about the cinema. Okay. State determination is good. Each and every single function is done. It does its own thing. We need to fix this. The weird part is the scale by mass is what triggers the state shift into stuckness. This only handles whether it's melting and whether it's growing. Scale by mass is the thing that actually determines whether or not it should move into stuck. And really, I can offload this entirely to something else. I can just make this only scale by mass, right? And make it be a boolean. So if it works, if it worked, return true. If not, return false. See that? Perfect. So we don't scale. We don't do anything if it can't do anything. If scale by mass, we do this. Then we say current state equals state that's stuck. There we go. Then we do determine stickiness. Which is itself its own signal backup. This is doing it like this is easier because then I can eventually loop it into the state machine very simply. It's very Really, this is a question of like how do you encode? How to encode conditions of a state machine within the state machine, separate from all else. And this involves like I've done this a couple times, but I can't recall them anymore. But basically, this involves having something that would modify those variables, and then you would have ways to modify them based on each state machine that it provides you. It's a magic. Magic. So what does it mean when it returns true or false? Maybe determine stickiness is a stupid term, but you kind of do want this like multi-step. So if it's currently stuck, or like if it's not moving, like there's no acceleration. Actually, this is also bad too. So to do this is awful because it forces a weird dependency where if something consumes the acceleration, it must know to leave it without doing anything to it. Otherwise, it'll disappear, Sag. Really, this should be a signal that this takes in that then takes that value, makes a defensive copy of it, and then makes it so that it determines the logic on the value that was given to some other source, and that value source can be modified at will. Sure. It's really only a safety thing, because then it's like you basically decouple the logic by just caching or copying the value yourself. It has to happen anytime that value changes, except for when it disappears. Doable. But what if it's meant to disappear? How do you differentiate when it's meant to disappear versus not? Fuck it. Whatever. For now, it's fine. If it's trying to, if it's no longer moving, then it's no longer stuck. So we return false. It's no longer stuck. If we return true, then it's still stuck. Return true, because it's still stuck. And really, this should just return like here anyways, because it's like it's gonna destroy it anyways, right? So it doesn't really matter. Well, yeah, because why increment a variable that's gonna disappear when it gets destroyed? Death mass? No. What's the thing again? What's the stuck? Stuck time threshold. Oh. Like how long before destruction, basically. Oops. Stuck time. Yeah. Okay. Time spent stuck. Death mass threshold. Determine if we're at the mass. So something else needs to determine if we should die. Well, I mean, really, the melting should only deal with that, right? It's to cause an issue where, like, if, for instance, plowable.mass less than death mass threshold. Let's say you're under, but right at that same frame. No, it's impossible. Just ignore that. Ignore those edge cases. Those edge cases don't change or like break the game. Those edge cases only make a slightly like very one in a million inconsistent experience for a fraction of a second. These are not edge cases that break the game. These are simply experiential edge cases that don't change anything meaningful about the game itself. So ignore the problem, foist it onto the player, let them deal with it, and if it breaks, it breaks. Cool. When in doubt, let your players handle it. Hope that they're fine. Well, now there's multiple things. Multiple things need to kill the object. Do we need to? I guess for now it's fine. We just do game object.destroy. It should be fine no matter what we do. So, do we need a state for dying? Maybe. Because don't you want like an animation to play? How would you play an animation? How do you play animations? How do you even do animations? Wait, how do you programmatically trigger an animation? I never thought about that. Where is the wiki? Animations. Aware. Yeah, I always try to avoid them too. Because animations are the one thing where it's like... Because animations are effectively a state machine. So effectively, how do you work with the state machine? But from code, the state machine has no clue what the values are. It's like stringly values, right? Because basically the state machine is just always stringly values, because that's the only way to encode it in a way that you can dynamically call things from code. So it's like a state machine that has no guaranteed compile time states, that you just have to memorize the mapping between the dynamic runtime setup configuration and the actual like compile time code, basically. There's techniques to mitigate that with code generation, where you could theoretically code gen like an enum or something, right? Based on configuration values. And really, that's sort of like what you kind of want anyways. But I didn't make Sandbox, and animation is within Sandbox. If I made it myself, I could do that for my own thing. But because it's within Sandbox, I can't really do that. Well, I could. I guess I could. Technically, the engine is simple enough that I can figure out where. Well, that's simple, but like the layer on top of the source engine is very well done and very understandable, so it's fine. Animations have multiple states. You have to lerp between states. Sounds fun. Well, so the lerping and stuff, that's really a function of the state machine itself. Oh. Okay, testing. Hello? Hello. We might be back? I don't know. Let's see. Sorry. I think I know why. I'm trying out some new thing, and I think the amount that I'm pushing through, it really doesn't like it. Okay. There we go. Yeah, sorry about that. It's because I was trying out like a new setup for a while now. It usually is okay for the setup to like push both streams because you know how I do the multi-streaming. I don't go through a third-party service. So I specifically go through like my own setup where I just push the stream to both sides. The problem with that is that I don't think it can manage. I don't think my connection can manage that many pushes. So the multi-streaming will have to be on some level fairly straightforward versus what we currently have. Because otherwise it's like way too much pressure downstream, I think. Or like way too much pressure upstream on my actual connection. And so it dies after a while, especially if it starts to push like too much stuff. However, that only really matters at the reconnection state. So if it dies, it's way longer to reconnect than it normally would. But if it's stable, it stays stable. So it's like when it gets bad, it gets bad. When it's good, it stays really good. So I'll figure that out. But the YouTube live stream is dead. Sorry, YouTube is. You just get nothing. But I was gonna say, lerping between animation states, that's separate, right? Like the state machine for animation really handles that itself, and you define that as a rule within the animation system itself. So, say for instance, you might do like IK. Well, not really IK, but like this, but the smooth lerping between animations is really a function of the animation state machine itself, and not really your code. You, from your code, you really ideally want to narrow it down to just transition to the state and handle and like run callbacks when you have those like state like these like transitions, right? So this idea of like the on, off, and like during, right? Your code should really only care about this, but your animations care about the lerping. But that's a part of the animation state machine itself, and not really a part of the state machine as you interface with it from code. Now you could from code. I think you could if you want to like programmatically make animations, especially for like stuff like very complex IK and like dynamic animation state and stuff, but I don't know if it's worth it for this game to worry about that. But I can see that being useful for another game concept I have in mind. So we'll see when we get there. But at least for this, it doesn't matter. But even for that, I feel like you still could just do it purely based on the animation system itself. And you just define the rules within the during part as part of the animation system, like UI in the editor, where it's better suited with the visual component. And then you do programmatically, it's more about reacting to these events, right? Like, it's different from like a state machine that you have to manage in and of yourself on your own within your own code, where you're primarily managing the state machine itself, right? If you just use a state machine, you're primarily reacting to the events. You're not also managing these like state transitions. So thankfully, they've done that themselves. The animation system is effectively a state machine. It's already handled by itself. I didn't have to make that work. But if I had to make my own animation system, I would have to handle all of that, which is, as you say, the like lerping between states, the smooth, like, you know, transition between like one set of animations on like a rig to another, like bones and stuff like that. We don't have to. So we don't have to care about that there. Nice and easy, nice and simple. What is wrong with you? Eh? Oh, right. Time spent stuck threshold. Yeah. Yeah, there we go. This though, but as I say, right? If we want to destroy the snowball, we have to apply, or like we have to tell the animation to kick it into the destruction animation at some point, right? At some point, the snowball has to know when to transition to a destroyed animation state. I don't know how this works, and it could just be that the animation system itself, the state machine, allows you to define it on that state. So we may not even have to kick it to that state manually ourselves. But it's worth it to check out now, I think, just to make sure, because we're kind of at the tail end anyway. So, anim graph. Let's go to not new. I didn't mean to do new. Sorry. Let's do Terry. How the fuck do I get Terry? I don't know. Hey, how do you get Terry? What is an anim graph? Wait, actually, step number 1. What is an animation graph? Model editor. Model doc. Sure. No, but I do probably want the animation graph. What's an easy way to get the pathway to Terry? Aha. Oh, sorry. Give me 1 second. Okay, so that. Maybe we just do this. Like, can I just copy this like pathway? Uh-oh. Well, that worked. Uh-huh. Here we go. Animation lists. We have a bunch of animation lists here. There's a unicycle? What? What? Unicycle? What the hell is that? Unicycle How do I remove the floor? How do I make the floor like a visible thing? Is he just dead? God. Oh, that he's literally just dead. Oh. Oh, right, because these are the leans, so it only animates the like head. These are meant to be played in a conjunction with like something. Yeah, see, it's an animation subtract. These are meant to be played with something else. So it's like you'd be standing. Say you have your default standing pose, like your default, then this would do an animation subtract only on the head. But I guess model doc, the way it displays it, because it's like like if there's nothing, because you can't like apply a base of it to display it with. I guess you just show this, like you just show this. It's interesting. Dab. That's disgusting. Crouch, idle pose, and blah blah blah. Anyways, these are the animations that we have. God, it's so weird. Look at him move. It's so disgusting. Ugh. But it's like he's the perfect character. Like I love that Terry looks disgusting because he's like the perfect character for a game because he just looks funny. You know what I mean? Like he just looks funny. So that's cool and all, but we need to open the no, wrong one. Sorry. Open an editor. How about is there a way to open it within the animation graph itself? I'd love to. And I guess it technically is the animation graph too. Like it's all in one, but anyway, so you have this, you have that. How do you? Well, maybe it's not really the animation graph. Like, how do you determine? Like, basically, how do you do this to then use it? Maybe there's documentation on it. Animations without anim graph. What? Performance bottleneck. Oh. Do all your animation stuff within model doc. It's similar to Source 1, except you're doing all of your work by the GPU itself. How do you do the conditions? Hmm. Hmm. So again, see, these are the animation sub tracks. So yeah, some of this is ringing bells in my head. I remember some of this to some degree. I see. Hmm. Yeah. Okay. Well, looks like this is it then. The animation graph. Okay, so model doc is where you make animations directly, and you apply stuff like all the complex stuff within like that you'd usually find in a QC file. And then you'd have to do the code wise. You'd have to apply the code yourself. Whereas animation graph is like it's a bit of it's a bit of both. Animation graph is effectively using it to create the animation types by combining different animations together from the animation list. This just defines what the animations look like within the animation list for a particular grouping. That's cool and all, but what does it mean that Anim Graph is slow? I guess it would be slow if it's all a visual scripting. Because maybe they don't have a way to compile down their visual scripting side yet. I mean, blueprints are pretty fast in UE4, or like UE5. Hard to compare when it compiles down very well. But maybe we do it ourselves. Maybe we do have to deal with it. Oh no. Maybe we do have to deal with it. Well, for a game, it doesn't matter. For our game, it doesn't matter, and maybe we could just make the anim graph better on our end once we like tweak into it, right? If we really have to. But it's going to impact one game in particular that I know that we're going to make by probably January. Because this month is this game. November is Nutcracker. December is the type battle game. January is that other game. Basically a game a month, right? We're aiming for a game a month. That's basically the flow of it. It's really going to come into play and be a problem by January. So we just use the system as is, and hopefully they fix it by then to be faster, and we reap the benefits, or they shut down s&box, in which case it doesn't really matter. We just go back to like maybe Godot. Maybe yeah, might as well. Okay, well, we know what to do. Animation's simple. It's fine. Do the above in anim graph. For now. No need to deal with it from here. It's fine. It's cool. But we could, and it's very simple. Because it's defined as like the QS or the QC file. So you have like the anim subtract and stuff, and then it's very easy to apply them on top of it because you take your base, and then you just define like a subtraction or like an addition, or well, it's basically always subtractions on top of whatever it is, and it's a very simple model to work with because then you define each part itself. And you just apply it onto a base animation set. So it's good. It's easy. It's easy. And then lerping is just a matter of like lerping from one bone to the next bone. Yeah. I've hit my limit. I know I said we'd get even more done, but I've hit my limit. Brain-wise, I need calories. And if I'm gonna go for calories, it's already end of stream anyways, because we're about half an hour out. So how about this? We go get calories. I go do my thing. I'll let you guys know when the theater is open. When the theater is open, I'll see you all over there. That's it for s&box. Thanks for watching. Again, we're trying to aim for like a game a month, and this game has to be done by Christmas anyway, so it doesn't really matter if we don't get it done immediately. Since we can get to the game jam again, but that's more of a like what can anyone do, right? Time is infinite. It keeps on going. Circumstances in like life. It's important to move on and never forget that we tried. And at least we're getting better and better at this, and we're understanding more and more about what this engine is and how to do things. And we're also kind of making sense of what we did before. Because whatever I did while we were trying to make the MVP doesn't make any sense. So I'll probably make a lot more progress off stream, and I'll probably just recap you. Because that's usually how it goes, is I make a lot more progress off stream compared to like doing it live on stream because of the like talking aspect. But it's been interesting programming streaming. It's really been practice for me to see like how you program streaming. And it's been very interesting for my anxiety too. Like I tend to have anxiety showing people my work in progress because like I worry like, is it good enough? And I realized something while doing this is that it's never good enough. So it doesn't matter. Like you might as well just show it anyways. It'll never be good enough if it isn't good enough. And that's really a subjective thing. So it doesn't really matter. So I like programming streaming. But that's it for the s&box segment. Hope you enjoyed. I swear to God, we'll actually get this game done.